Hi, I'm Richard, and we are here in one of the electron microscopy labs at GFZ Potsdam. And I'm a geologist from my background, and I'm working with TEM since more than 3 decades. And through that time, I could get a lot of experience about the application of TEM in geoscience and the usefulness of TEM for geoscience. If we think about using TEM in geoscience, we think about exploring geological materials like rocks or minerals beyond the microprobe, the electron microprobe, because we have a much better resolution, and it's a totally different world what we explore here. And the basic, what we can get out of these investigations is information about the microstructure and nanostructure of minerals and rocks, such as twins, exsolutions, grain boundary migration, and dislocations. And this gives us information about the history of the rock with respect to pressure and temperature, and, for example, the dislocation history of the rock. So very interesting, and a lot of important information can be derived from TEM studies on geological samples. A basic requirement for studying geological samples in TEM is that we need a very thin sample. And thin means less than 150 nanometers thickness, or 0.15 micrometer. And that can be achieved by using a thin section. And from this thin section, we can select an area which is of interest. And this is a great advantage, to have an area of interest and not a random area. And from this area of interest, we can cut a foil with the dimensions approximately 15 to 20 micrometer wide and 10 micrometer high, and less than 150 nanometer thick. So it needs to be electron transparent. And this sample preparation is done with a focused ion beam system, and it allows us to do site-specific sample preparation, which is a great advantage. And then this sample can be, it's a very tiny sample, it can be loaded into a specimen holder, and this specimen holder is now inserted into the electron microscope and is penetrated by the electrons, which come from an electron source, and these electrons are accelerated to 300 or 200 keV, and the electrons penetrate through the sample and interact with the sample, and a lot of scattering events take place, and these scattering events, they are used for image formation, as is shown here in the background on one of these screens. And a second interaction is that we excite X-ray photons in the sample. And these X-ray photons can be used for chemical analysis of the sample. This is a TEM foil from a cassiterite, which is basically a tin oxide. And this width here is approximately 15 micron, and the height is approximately 10 micron. And on top, we see a protection layer for the focused ion beam sample preparation. And the interesting thing here is that we observe these brighter and darker lamella. And if we look in more detail, which is seen here, we see that these lamella are composed of smaller lamellas, which are normal to each other, which is shown in this dark area here. And of course, we want to know, this is a question here, what are these lamella composed of? What is the microstructure here, and what are these lamella? And therefore, we use an area, for example, like here, for high-resolution imaging. Note that the scale bar here is only 20 nanometers. So the width of this lamella here is approximately 100 nanometers or so. And if we use a high-resolution imaging technique, from this area, we can see that these dark lamella are normal to each other and the bright lamella are also normal to each other. And we can identify them by electron diffraction pattern. This is indexed as a cassiterite with more iron. So it's basically the same crystal structure. And we can also get chemical information from such a small area by using the excited X-ray photons, which is shown here. And here we see the iron peak, which comes from this lamella. So this is a nice example what can be done with TEM and what the general application is in TEM. And I want to finish here, and I want to mention that in June, from June 5th to June 9th, we will have a short course in Western Cape, at the Western Cape University in Cape Town, where I will give an introduction in theory on image formation and scattering theory to understand what kind of images we see here. And also, and this is a major objection of this course, the application of electron microscopy in geoscience. And finally, I want to invite young researchers to come with their project to Germany, to GFZ, in our labs, to do transmission electron microscopy there. It's free of charge, and it's certainly a great benefit for young researchers and their projects. Thank you very much.